we want to take just a moment to recall what exponents are. So for instance, if I had x to the fourth power, the 4, or the power, is the exponent. And what that exponent does is tells me that I have 4 x's, 1, 2, 3, 4, being multiplied together. So I have this repeated multiplication of these 4 x's. That's x to the 4th. Now everything that we learn about exponents will come back to the idea that x to some power is that many x's being multiplied together. Now, as long as we've got that in our minds, let's actually look at some of the properties we're going to be dealing with. Now, there are 6 of them in all that we're going to be concerned with. The first one is called the product of powers. Powers, of course, are exponents. A product is the result of multiplication. So what we're talking about here is the multiplication of exponents. So when we multiply terms that have exponents, we use the product of powers. Now I have a to the m times a to the n. Notice that both of these have a in them as the big number. The big number is usually referred to as the base. So a in this case is the base, with m and n being exponents. If I have 2 numbers that I'm multiplying together and they have the same base, I'm going to add the exponents. So a to the m power times a to the nth power becomes a to the m plus n. A to the m plus n. So multiplying the terms resulted in adding the exponents. And if we see an example here, it would look like this. If I had x squared times x to the 3rd, that would be x to the 2 plus 3, which equals x to the 5th. Now, of course, I don't have to write this step out every single time. Once I've got the idea, I can just jump right to it. Now, in the next example here, the power of a power. Now, a power, of course, is exponent. And we're taking the exponent of an exponent. That means we're going to raise something that already has an exponent to another power. So an exponent of an exponent. When we do that, I have, in this case, a to the m to the nth power becomes a to the m times n. So I multiply m and n. So raising to an exponent resulted in multiplying the exponents. An example, for instance, might be if I had x squared and I raised x squared to the 3rd power. Now keep in mind that would be x squared times x squared times x squared, because it would be 3 x squares multiplied together. And of course, using the product of powers, I could say this is 2 plus 2 plus 2, which is x to the 6th. But the easier way would be to say that this is x to the 2 times 3. These are both identical statements. X squared plus x squared plus x squared, or times x squared times x squared times x squared, is the same thing as x to the 2 times 3. So that's the way we're going to think of it. We're going to think of this as x to the 2 times 3, which is x to the 6th. Now the next product, the power of a product, is when we have an exponent, power exponent, of multiplication, because product, remember, is multiplication. So if I have the exponent of multiplication, or if I had a times b to the mth power, what that would look like would be a to the m times b to the m. So both of my individual terms got raised to the mth power. An example of that, we'll have a look here, would be, for instance, if I had x, y, two terms being multiplied together, raised to the second power. Well, it would be x raised to the second power times y raised to the second power. That will be the result. Moving on. Here I have a negative exponent. So if I have an exponent that's a negative number, this one's kind of an oddball here. If I had, for instance, a to the negative mth, here's how this would look. I would take this. Now, the first thing we need to do is realize that a to the negative mth is always over 1. Every single number that we deal with is always itself over 1. Now, what we want to do here is this negative exponent takes the entire term, a to the negative mth, the entire term will flip upside down, right? You'll find that you'll take the reciprocal. Remember reciprocal. The reciprocal of 2 is 1 over 2. The reciprocal of 1 over 3 is 3 over 1, which is just 3. So I have a to the negative m over 1 becomes 1 over a to the m. Notice that the negative sign went away when I took the reciprocal. And that's really all the negative sign tells you to do with exponents, is take the reciprocal. An example of this would be if we had, say, x to the negative second. Well, that would be 1 over x to the second, and that's it. We don't have to go any further with it. The quotient of powers, now quotient, you should remember, is dividing. So the quotient is divide. So if we divide terms with exponents, such as a to the m over a to the n, the result of that would be a to the m minus n. We subtract the bottom from the top, so m minus n. An example here, we would have, for instance, x squared over x to the third would be x to the 2 minus 3. 2 minus 3 is negative 1, so it would be x to the negative first. And we could either write our answer as x to the negative first, or, as you may have guessed, 1 over x, because that negative first tells us to take the inverse, the reciprocal. Alright, here we are. Power of a quotient. Of course, power is exponent, and quotient is divide. So if we're taking the power of a quotient, that means we're giving something that's being divided a power. In this case, I have a over b to the mth power. And what all that does is give me a to the m over b to the m. That's it. So an example might be if I had x over y to the third, that would be equal to x to the third over y to the third.